Hey everyone, and welcome. So, we've all been there, right? You're starting a brand new project in Unity, you're super excited, you get your player character moving around, you hit that play button, you start moving, and they just drive right off the edge of the screen into nothingness. Well, today we're going to fix that once and for all. We are diving deep into one of the most fundamental mechanics in all of game development, the follow camera. And we're not going to just click a button or use a pre-built asset. No, we're building this thing from scratch, using C# code, so you'll understand exactly how it works under the hood.
So just imagine it. You've got this awesome player character. Maybe it's a race car, maybe it's a little hero on an adventure. You've got the movement feeling just right. You hit play, you push forward on the joystick, and they take off. It feels great for about 2 seconds until poof, they're gone. They've driven right out of the frame, and you're left just staring at an empty, boring patch of ground. This is the classic problem we're here to solve. We need a camera that's smart, a camera that's attached to our player like a loyal sidekick, keeping all the action right where we can see it.
Okay, so first things first, let's break down the actual problem. When you start a new scene in Unity, you get a main camera for free, but it's just a dumb object. Seriously, think of it like a security camera that's been bolted to the ceiling of a room. It sees what it sees from one fixed position, and that's it. It has no idea that your player even exists, let alone that it's moving around. We're going to see exactly why this default static camera just doesn't work for pretty much any game where the player can, move. On the surface, our goal sounds almost laughably simple, doesn't it? We just want the camera's position to always match the car's position. That's it. If the car moves forward, the camera moves forward. If the car turns left, the camera turns left with it. It's a simple, logical, one-to-one relationship. We want to lock that car in the center of our screen and never let it go. And that one simple idea, that's the foundation for every single thing we're about to build.
Now, before we start writing code, I have to make a quick but really important point. Unity has this incredible, powerful tool called Cinemachine. It's a whole package that lets you create amazing cinematic cameras without writing any code at all. It's awesome, and you should definitely check it out later. But today, we're doing it the old-fashioned way. We're doing it ourselves. Why? Well, think of it this way. Cinemachine is like driving an automatic car. It's easy, it's smooth, it gets you where you need to go, but learning to code the camera yourself, that's like learning to drive a stick shift. It's a little trickier at first, but man, once you get it, you understand the machine on a whole different level, and you have so much more power and control. That's what we're after today.
All right, enough talk. Let's roll up our sleeves and actually get to work. In this section, we're going to jump into Unity and create our very first C# script. This little text file is going to be the brain of our camera, telling it exactly what to do, what to follow, and how to follow it. This is where the real fun starts.
Okay, so setting this up is super easy. Let's do it together step by step. Go into your Unity editor and find your assets window, probably at the bottom of the screen. I want you to right-click in an empty space there, go up to Create, and then slide over and click C# script. A new file will pop up, ready to be named. Let's call it Follow Camera. And pay attention to how I type that. Capital F, capital C, no spaces. That's a coding convention called Pascal case, and it's just a really good habit to get into for keeping your projects organized. Now for the most important part. A script doesn't do anything unless it's attached to an object in our scene. So who is the script for? It's for the camera, right? So we're going to attach it to the camera. Find your main camera in the hierarchy list on the left, then just click and drag your new follow camera script from your assets right on top of it. You'll see it pop up in the inspector window on the right as a new component. Perfect. Now we're all set up. Go ahead and double-click that script asset to open it up in your code editor. Okay, so before we write the main logic, we have to grasp one super important concept in programming, a reference. Think about it. Our follow camera script is sitting there on the camera, but it's in its own little world. It has no idea that the car even exists. We need a way to connect them, to tell our script, hey, you, look over there. See that thing? That's the car. That's the object you need to be following. This connection, this pointer to another object, is called a reference. Without it, our script is totally lost. So how do we make that connection in our code? It's literally this one line of code right here. Let's break it down word by word. First, private game object thing to follow. The private part just means this variable is for this script's eyes only, which is good practice. Game object tells Unity, hey, this variable is designed to hold any object from our game scene. And thing to follow is just the name we decided to give it. But the real star of the show is that little tag in the brackets above, serialized field. This is like a magic instruction for Unity. Normally, private variables are totally hidden inside the Unity editor. But serialized field says, I know this is private, but please make a little slot for it in the inspector so I can easily drag something into it.
It gives us the perfect combination of safe, clean code and a super user-friendly way to link our objects together. Let's jump back to Unity and actually hook this up. It's super satisfying. First, click on your main camera in the hierarchy so you can see its details in the inspector on the right. Now, scroll down in the inspector until you see our follow camera script component. And look, because we added that serialized field tag, there's a new field there called thing to follow. Right now it says none. All you have to do is go back to your hierarchy, find your player car object, click and hold on it, and then physically drag it across the screen and drop it right into that thing to follow slot. You'll see the name of your car pop up in the field, and boom! Just like that, our script now knows exactly what object it's supposed to be tracking. The connection is made. We are finally ready for the main event, the actual logic. Inside your script, you'll see a function called update. This is a special function that Unity calls automatically, over and over, once for every single frame of the game. It's the heartbeat of our script. Inside of update, we're going to write this one powerful line. Transform.position equals thing to follow.transform.position. Let's translate that from code to English. The first part, transform.position with a lowercase t, means the position of the object this script is attached to. Since our script is on the camera, this just means the camera's position. The second part, thing to follow.transform.position, means go to the object we're following and get its position. So what we're telling the engine every single frame is take the camera's position and make it exactly, perfectly, 100% identical to the car's position. Seems like it should work perfectly, right?
All right, the moment of truth has arrived. We've written our code, we've hooked up our reference. Let's hit that play button in Unity and watch our masterpiece come to life. But get ready for a bit of a surprise. Our perfectly logical code is about to have a very unexpected result. And figuring out why is the next crucial step on our journey. You hit play and whoa, what is that? Your game screen is probably just a solid color. Or maybe you're seeing the inside of your car model, all weird and distorted. So what on earth just happened? Well, our code did its job, a little too well. We told it to make the camera's position identical to the car's position. So right now, the camera is literally inside the car. It's like you've shrunk down and are standing at the absolute center point of the car model. Of course you can't see the car. Your viewpoint is inside of it. So here's the flaw in our logic. We achieved a perfect one-to-one position match. If the car's coordinates are x, y, and z, then the camera's coordinates are the exact same x, y, and z. There is zero distance between the viewer and the subject. But to actually see something, you need some distance, right? We don't want the camera to be at the car. We want it to be a little bit behind the car and maybe a little bit above it. We need to introduce an offset. And how do we represent that offset in code? We use one of the most important tools in 3D game development, a vector 3. Now that might sound like a complicated math term, but don't worry, it's really simple. A vector 3 is just a tidy little package that holds 3 numbers, an x value, a y value, and a z value. That's it. It's the perfect way to represent anything that has a position or a direction in 3D space. And for us right now, it's the perfect tool to define the exact offset we want our camera to have. So here is our fix, and it's a beautifully simple change. We're taking our original line of code, and we're just adding something to it. The new line says transform.position equals thing to follow.transform.position plus new vector 3 of 0, 0, negative 10. What we're doing is taking the car's position, and then we're adding a brand new vector 3 to it. We've set the x and y values to 0 because we want to stay directly behind the car, not off to the side or way up in the air. But we've set the z value to negative 10. In Unity, the z-axis typically points into the screen, so a negative z value actually pushes the camera backwards, away from the car. So our new instruction is much smarter. Every frame, find the car's position, then move back 10 units, and make that the camera's new position. Okay, let's hit play now, and yes, it works! The camera is following the car from a nice, steady distance. We can drive all over the place, and it stays right with us. Success. So we're done, right? Well, not quite. We can do better. There's one last, very subtle issue that separates a decent camera from a truly professional, silky smooth camera. Let's talk about camera jitter. You might not even notice it right away, but if you look closely, especially as your game gets more complex, you might see a tiny little stutter or shake in the camera's movement. It's not perfectly smooth. It feels a little jittery. So what causes this? It's not a mistake in our math or our logic. The problem is all about timing. It's about the order in which things happen inside a single frame of the game. This problem is what programmers call a race condition. Think about it. Every frame, two things need to happen. The car needs to move, and the camera needs to follow it. Both of those pieces of logic are happening inside the update function, but Unity doesn't give us a guarantee about which script's update function will run first. So one frame, maybe the car moves first, and then the camera moves to its new position. Perfect. But the very next frame, maybe the camera's update runs first, so it moves to where the car was last frame. Then the car moves. This tiny inconsistency, this constant swapping of who wins the race each frame, creates that visible stutter. So how do we stop this race? How do we make sure our camera is always perfectly smooth every single time, no matter what? Well, the solution is actually incredibly simple and elegant. We don't need to change our logic at all. We just need to move our logic to a different special function that Unity provides for exactly this kind of situation. Let's compare update and late update. Update is where almost everything happens. It's where you check for keyboard presses, where you move your characters, where you calculate physics. It's the main stage. But late update is a special function that is absolutely 100% guaranteed to run after every single update function has finished for the frame. You can think of it like this. Update is when all the actors on stage move to their new positions. Late update is when the camera crew moves into place to film them in their final spots for that scene. It always happens last, which makes it the absolute perfect place for camera code. And this is it, our final, polished, professional camera code. Now look very closely at it. The line of logic inside the function is exactly the same as before. The only thing we have changed is the name of the function itself. We simply renamed void update to void late update. That's it. By making that one-word change, we have completely fixed the race condition. Now we are telling Unity, hey, go ahead and let the car do all its movement in update, I'll wait, then when everything else is done moving for the frame, I'll run my camera logic. This guarantees a perfectly smooth, jitter-free follow every single time. So let's just quickly recap everything we've learned today. Number 1, the code that controls an object should live on that object. Our camera script goes right on the camera. Number 2, serialized field is your best friend. It lets you write safe, private code while still having easy, drag-and-drop connections in the editor. Number 3, you can't just match positions. You almost always need a vector 3 offset to get the camera into the right viewing spot. And finally, the pro move, camera logic always goes in late update to guarantee that buttery smooth motion by avoiding race conditions. And with that, we're done. You didn't just follow a tutorial today, you built a core game mechanic from the ground up, and hopefully you understand the why behind every single line of code. This is a huge building block, and now that you have this solid foundation, the sky is the limit. What are you going to build next? You could add code to make the camera zoom in when the car goes fast. You could let the player use the mouse to orbit around the car. This is your starting point. You now have the skills to start building even more amazing camera systems. Fantastic work today, and I can't wait to see you in the next explainer.